Hi, everyone, and welcome to episode 31 of Diabetics for Diabetics Radio. I'm your host, Bowie Madison. Today's episode, we're talking about the current theories on the development of diabetes. So, not just breaking down each of the reasons we think diabetes came about in the first place, but looking for common threads and things that are connecting them beyond just the theory itself. So, if we have not met, my name is Bowie. I've had type 1 diabetes for 22 years now. That slide isn't updated. So I just had my 22nd diabetiversary in August this past year. I have spent the past 2 years sharing my healing journey, going through natural paths, kind of the marginal spaces in alternative health to not just mitigate inflammation, but also regenerate beta cells and ultimately heal the diabetic condition. I've done most of my sharing on TikTok. You can see my handle there at Bowie_Madison. And of course, the podcast here, go ahead and subscribe to my channel for both podcast episodes as well as shorts and breakdowns on what it is I'm covering. So today, like I mentioned, we're going to talk about all of the different theories behind how diabetes came about. And you've definitely heard of at least one of these, probably at least 2 or 3 or 4 plus, but I wanted to take a brief view at each of them. Now, this particular episode isn't going to be a deep, thorough breakdown of each of these. Every one of these pathologies and theories deserves a podcast episode of its own. This is kind of touching on each of these to not only learn about what they are, but also introduce questions that you can use on your own as you start to look a little bit deeper yourself. So the first one that we're going to talk about is the genetic component of diabetes. Now, this, I would argue, is the most prevalent, the most popular, right? The one that every diabetic gets no matter what when they get diagnosed, right? Everyone remembers that first endocrinologist visit, or, when you were in the hospital and you found out that you had type 1, the educator coming in and letting you know how this happened. And genetics is almost always part of that conversation. Now, the depth of the genetic nature of what's going on is never discussed. It's just kind of, we think it has something to do with genetics and there's nothing we know to do for it. So, tough luck. But for a long time, it has been labeled a genetic disorder. Now, I mentioned before the loose language that goes on when we describe the ties behind genes and diabetes. It's of a genetic origin with genetic components. Having certain gene variants increases the risk, but nothing very definitive. And as we'll see, there's a reason for that. There are several genes and their variants that have been correlated with type 1 diabetes. In total, over 60 of them, over 60 different genes and different loci within those genes. The ones that get thrown around the most are the HLA genes, or human leukocyte antigen genes. We'll talk more about them a little bit later on as well. But lots to look into with diabetes and genetics. And I always reference the medline.gov, which is government-sponsored information regarding diabetes, treatments, causes, symptoms, what have you. And in the causes tab for type 1 diabetes, it gives a pretty good breakdown of the summaries of the information going on about the genetic origin of diabetes. And again, they do not withhold that they don't know, right? So the causes of type 1 diabetes are unknown. Several risk factors have been identified, some of those being the variants regarding the HLA gene, which they go on to say belong to the family of genes called the human leukocyte antigen complex. Now, the HLA complex helps the immune system distinguish the body's own proteins from proteins made by foreign invaders such as viruses and bacteria. Now, when you read that, that makes sense, right? Because we've been told for the longest time that diabetes is of an autoimmune origin, right? So it's of an autoimmune origin, which means that our immune system wrongly identified our beta cells, released antibodies to attack and neutralize those beta cells, which resulted in us becoming diabetic. So that fits in because HLA is responsible for that. So that must mean a dysregulated or a changed HLA variant is the reason that our beta cells were recognized as foe and not friend. But if you keep reading in that same section, they talk about all of the different types of HLA genes, over 60 of them from a different source, but all of the different types of HLA. Now, these haplotypes seem to increase the risk of an inappropriate immune response against the beta cells. Now, here comes the underlined version. However, these variants are also found in the general population. Okay, so a lot of people tend to have these HLA variants. And only about 5% of individuals with the gene variants actually develop type 1 diabetes. So you have to be asking yourself, if these genes truly do correlate with diabetes, why don't people with these genes actually get diabetes? 95% of the people with these particular HLA variants don't get diabetes. And yet the people getting diabetes are being told, well, these are kind of the reason that you are. Meanwhile, 95% don't. That doesn't line up for me. And so the genetic theory paints a messy, messy picture because, first off, those HLA genes that we talked about, the human leukocyte antigen complex, they happen to be present in a lot of different autoimmune conditions, not just diabetes. Now, they're responsible for immune system activation, so they do have a role because obviously the immune system's job is to identify foreign invaders and protect them from the self. Now, only 5% of the people with those particular genes and variants actually get the disease. That is a very, very poor correlation, right? And to this top point, HLA being ubiquitous in autoimmune disorders, there's even a paper here talking about how nearly half of those at genetic risk because of those HLA genes there's a paper here talking about how HLA variants are responsible for nearly half of the genetic risk for autoimmune diseases. So there's no denying the tie to autoimmunity or an inappropriate immune response, but to have it be simultaneously so present in so many different diseases, and even with that being so rare in actually causing diabetes, it's not conclusive. There's nothing cut and dry about it. So keep that in mind. When you're talking about genes and diabetes, you have to consider a few things. So what are the other factors influencing those 5% of the people with the diabetes genes that actually get diabetes? Because obviously it's not the gene itself. If it was the gene itself, the rate of getting diabetes with those genes would be significantly higher, right? And then anytime you talk about diabetes, and genes, you have to consider DNA, right? Is the DNA being changed somehow? If DNA is changing, is it being able to be repaired? Is it a mechanism that's helping it survive? Is it a self-destruction mechanism? So is this really a problem with the DNA, or is this a problem with the tools needed to help fix the DNA? That's also another factor. And then, is there any more information regarding the HLA complex that can shed light on its ties to autoimmune disease? We mentioned before how prevalent HLA is in all autoimmune diseases. So what's a common factor in those diseases that we could help bring over to diabetes? And not to mention that with diseases that the HLA is very prevalent in, like rheumatoid arthritis and multiple sclerosis, why are people with those conditions not being given the same, oh, it's genetic, tough luck speech that type 1 diabetics are getting? Do you know anyone with rheumatoid arthritis that's being told it's genetic and that there's nothing they can do? Not really, not the same way that diabetics are. So I definitely have questions surrounding that. Next up, we have diabetes and parasites. So much of the information here is anecdotal. Okay, so parasites is something in Western medicine that is not spoken about a lot. For whatever reason, I do not know. Much of the information that I've come across and my introduction to it in general, I've had diabetes for over 20 years. Didn't hear about any sort of parasitic origins until like 2 years ago when I found it on social media. Because it's not being covered in the mainstream with a lot of the sources and resources that we trust to make a topic relevant, all of the evidence and stories regarding parasites is sort of anecdotal. Because it counters the pharmaceutical narrative accepted in Western medicine, there are a lot of very inexpensive and natural ways to handle parasites. Being natural and naturopathic, it tends to be less profitable, which makes it less interesting to the West. So there's very little comprehensive data in the research because of that lack of funding and that lack of interest. But that doesn't mean that there isn't something there, which is why I look. So what are we looking for and why? So there are a couple different types of parasites that have more prevalence in disease states. One of which is the liver fluke. That is something that is very popular in social media, talking about how liver flukes actually cause diabetes. People with type 2 diabetes have taken medications to treat liver flukes and their diabetes goes away. Again, there's no research supporting this. It's all anecdotal. Very few people talk about it openly, but we're making do with the information that we have. So out of this paper, we found that liver flukes are obviously of the liver being the primary source of creating bile and the origin of the biliary system, or the releasing bile and digesting fats. So liver fluke disease is a chronic parasitic inflammatory disease of the bile ducts. So the adult flukes of several different types of liver flukes settle in these small ducts and live there for 20 to 30 years. That is a long time. So these long-lived flukes, because they're living there, they are living, breathing, excreting waste, making eggs, what have you. And they're there for so long, it creates a long-lasting chronic inflammatory response in these bile ducts. And then this can cause inflammatory complications, hyperplasia, fibrosis, as well as collapsing of the bile ducts, right? So interesting thing is the vast majority of patients are asymptomatic, supposedly asymptomatic. They not in a way that can be traced to these flukes specifically, but the complications are stone formation, recurrent pyogenic cholangitis, which is inflammation of the bile duct, inflammation of the gallbladder, right? Cholangiocarcinoma is cancer of the gallbladder. So anybody dealing with gallbladder issues, stone formation, liver flukes tend to congest and complicate that system. Now, I've talked before about how one of my greatest healing experiences had to do with the flushing of gallstones, of bile stones, of liver stones. And when I read this paper talking about how liver flukes cause an abundance of bile stones, gallstones, I was intrigued because I had no inclinations that I had any deficits in my liver, my gallbladder, my ability to digest fats, anything. I tried this liver flush on a recommendation of a practitioner I was seeing, not knowing what to expect. And over the course of 6 months, which was anywhere from 6 to 8 flushes, I passed over 1,000 gallstones. And that's not hyperbole. I'm not overstating that. I mean that. Anywhere from the size of lentils, so something very, very small, all the way up to something the size of probably a nickel or a quarter, like very, very large gallstones. Again, I had no idea they were there. I had no reason to believe that they were there. But when I got rid of them, my health improved immensely. My digestion, my skin health, my energy levels, it was amazing. So when I found out that liver flukes are tied with bile stone formation, it really hit home for me, and I definitely wanted to look more into this. And then that snowballed into a bunch of different types of parasites. So pinworms, roundworms, protozoans, these single cell organisms, roundworms or pinworms. Pinworms aren't necessarily roundworms. There's a lot of different species of parasites that exist within the human body. Now, we don't know exactly what is bad and what is good. And I mean that in terms, think of it like bacteria, right? The human body is not the human body without some sort of bacterial presence, right? There is some sort of symbiosis going on here. And it's believed that parasites can operate in the same way. Now, it's unclear whether or not parasites are all bad, right? Think of it like bacteria. Part of the human existence, part of what makes humans humans, is their relationship with bacteria. It's a certain balance of bacteria, the flora in our gut, on our skin, all over. The same can be true for parasites. It's not clear to me, based on my reading, what that balance is. Now, I don't think that it's a complete, it'd be so difficult to rid yourself of parasites, and we don't even know if that would be a good thing, right? There's new evidence coming out now that parasitic presence in your body can actually fight disease. So it's less about extermination and more about finding balance and getting rid of the bad to allow for the good. So that's kind of where this research leads to, in my opinion. So this particular study, Intestinal Parasites and Diabetes, a systemic review and meta-analyses from earlier this year, they pooled data on IPs, which is intestinal parasites in diabetic patients. And they found that just under 30% of those with diabetes had a higher rate of parasites than a certain species of parasites to those compared to controls, which were not diabetic. So when you look at the diabetes parasite connection possibilities, like with the liver flukes, they can live there a long time. They're going through their life cycles, birthing, living, coming of age, laying eggs, dying off, having those eggs hatch, right? So that is all linked to a prolonged inflammatory response, which could be initiating an immune response. It could be making an existing response worse. Again, they're there for multiple years, right? With differing degrees of parasite proliferation. Some are laying thousands of eggs, right? And given by the name is parasite. Parasite by definition is something that is stealing resources at the expense of the host. So what are the effects of the food that we're eating that the parasites are taking? What nutrients are the parasites taking that, and what is that costing us, the host? It also has direct ties to liver and pancreas health because of the particular tissue infestation. For example, the liver flukes tied directly to liver tissue. We've talked before in this podcast about how important liver health is on the health of the pancreas, right? So is there something organ specific about certain parasites that make them more dangerous to a diabetic? That could be through the creation of fibrotic tissue, the immune response on those specific tissues, blocking the biliary system with those gallstones, the lymphatic system, and preventing the proper movement of lymph, and basically blocking the flow of immune support flowing through our lymphatic system. So that's still not clear. But you have to wonder, after reading a little bit about it, is there a normal amount of parasites, right? Do we want to get rid of them all, or is this something where things have just gone awry and there's too many, or they're out of balance? How can we strike that balance where we have a symbiotic relationship with these parasites? Are there some that are more harmful than others? What are the treatments that I can do to strike a balance? Kill off the bad? Are there certain strategies to killing them off effectively with all of these eggs being laid and all of the tissues affected? And why are they there in the first place, right? What made it possible? What about our bodily environment made it possible for them to find a home for so long? They wouldn't be there if the environment wasn't good for them. So what's something that we can do to alter our body to make it less of a good place to live for these parasites? Next up, we are here to talk about the virus and bacterial origins of diabetes. Now, with all of these names listed here, I'm not going to go one by one and talk about these. These are just certain viruses that have been shown to increase autoimmune reactions and the development of autoimmune conditions, right? So enterovirus, rotavirus, cytomegalovirus, Epstein-Barr virus, which is extremely popular right now, pericovirus, influenza, just a typical flu, parvovirus, mumps, rubella, human endogenous retrovirus, okay? So enterovirus tends to be the most prevalent in diabetics, particularly type 1 diabetics. So you can see here in this paper, they found that there was an association between the development of diabetes and enterovirus infection, and that the connection was strong, with almost 10 times the odds of having an enterovirus infection for those diagnosed with type 1. So if you have type 1 diabetes, the chances of you having an enterovirus in your body is 10 times greater than if you did not have type 1 diabetes. And there are a lot of different ways in which that could possibly lead to the development of diabetes. So you can see here, up here at the top, number one, direct infection. So this is the virus coming in to the body and directly affecting the beta cells. They are going to the pancreas, to the beta cells, infecting the cells and taking them over, right? Thereby disarming their ability to create insulin, causing an immune response. And there's that. Then there is the bystander activation. So the virus invades, it creates this inflammatory response, which inadvertently targets beta cells, right? And this could be through some sort of mimicry, like the virus itself looks similar to beta cells, so that when the virus causes antibodies to be created, they not only target the virus, but they also target the beta cells. And this leads to the development of the disease, which is mentioned down here in number 4, too, molecular mimicry, in that the viral proteins look like beta cells and cause for everything to get killed off. There's also dysregulation of mitochondrial RNA. So again, all having to do with kind of a ROS and inflammatory response. The virus invades the pancreas, causes a pro-inflammatory response, which alters the DNA in the mitochondria of the beta cells, causing there to be an alteration of energy, right? So it basically kind of hits the kill switch on the engine of the beta cells, and the beta cells end up dying. And then the chronic aspect of it, number 5 over here, the persistent infection, the fact that the virus persists, whether dormant or active, always eliciting some sort of inflammatory response, which eventually just degrades the bodily system as a whole, leading to beta cell die-off. And another aspect of the virus-diabetes connection, which I had never known about until I started researching for this episode, is that the seasonality of being diagnosed with type 1 diabetes is something I had never known. The colder months have higher rates of type 1 diabetes diagnoses. Did you know about that? I didn't know about that. So, turns out they started paying attention in the 1920s. They found that in those times of seasonal change, you have those seasonal flus in there. We mentioned before that influenza has a role, has a tie to the development of autoimmune conditions. But it's been confirmed that there are peaks in diagnoses of type 1 diabetes that correlate with seasonal changes. So when you look at the diabetes viral connection, there are things you have to consider, right? So this is from the paper we just talked about, the seasonality of diabetes. So whilst viral infection alone may not be sufficient to induce type 1 diabetes in any individual, a number of factors such as timing, the site, viral load, strain, and type of infection in combination with host genetics and the pancreatic microenvironment has been highlighted as critical for disease pathogenesis. So that's to say that the authors of this particular paper are saying maybe it's not just the virus itself, it's the virus being the straw that broke the camel's back amongst a sea of other straws, things like the timing, right, in time with the seasons, the change of the seasons, the type of infection. It could be any of the ones we mentioned before, with mimicking beta cells, messing with mitochondrial DNA, are beta cells being an innocent bystander to the immune response designated for the virus? You know, Who knows? There's a lot going on. So another thing to ask is correlation does not imply causation, right? So they're saying that people with type 1 diabetes are 10 times more likely to have an enterovirus. Does that mean that the enterovirus means that you have diabetes, or does getting diabetes make you more susceptible to the enterovirus? That we don't know. So ongoing research on the structural and pathological mechanisms for the ties between viruses and diabetes. They talk about the downstream effect on a particular pathway called the JAK-STAT pathway, which has to do with an immune response that causes DNA damage, DNA oxidation. Coincidentally, it's affecting the HLA genes, which we mentioned before are those labeled the diabetes genes. Direct beta cell infection, are they actually attacking the beta cells, or are they mimicking things similar to the beta cells, and the beta cells are just kind of inadvertently being killed off, right? And I mentioned this before, chicken or the egg. Is the virus causing the immune system to react, or is our immune system changed beforehand, allowing for these viruses to take hold? We have yet to know. Now let's go ahead and talk a little bit more. About heavy metals and environmental toxins. So a lot of people on social media are talking about heavy metal load, right? Heavy metal detox. You can take things like Shilajit, zeolite. You can do activated charcoal. You can do bentonite clay. There's lots of different ways to bind heavy metals, chelate heavy metals. But if you were to ask the average person participating in those heavy metal detoxes what those heavy metals were, I don't know that a lot of them would actually be able to tell you the specific metals that they were targeting. So when you talk about heavy metals, you're talking about any number of a few. So arsenic, lead, cadmium, mercury, chromium, zinc, nickel. There's also iron, copper, tin. There's a couple different others, but the paper that I'm going to be focusing on is going to be talking about these specifically. Now, you may be asking yourself, well, where do these heavy metals come from? I've lived a normal life. I'm not going out of my way to put heavy metals in my body. Where does it come from? Drinking water, tap water, public water. The way it's filtered, it's pretty poor in regards to reducing the amounts of water, especially in home filtration systems. I grew up on well water, and I know for sure that given the state of my home filters, when I see them changed, there is more in the water than meets the eye. So drinking water, exposure to electronics, and the fact that our hands and our skin are always in contact with some sort of plastic, metal, silicon surface. Our skin is our biggest site of absorption. Contaminated foods, right? So drinking water, you use contaminated water on those foods. Those foods are able to take those metals up, and when we eat those foods, we also get the metals. Smoking, cadmium, I believe the heavy metal cadmium is very prevalent in cigarette smoke. So those that smoke, air pollution in general, if you're living in cities with smog or next to airports, things like that, the combustion fuel or the combustion smoke contains a lot of heavy metals that can affect you if you're breathing them in over a long period of time. And here are just a few from the paper. Here are just a few on paper I'll have cited. Here are just a few from a paper I'll have listed in the description, talking about each of the different ones. Now, notice that each of them has a different relationship, right? So first one is zinc, right? Zinc, when we think of zinc, we think of it as a good thing, right? It's definitely something that we need to support our immune system. It's got roles in insulin release as well. And you can see this particular study, zinc deficient rats had serum levels down, glucose intolerance was up, right? So this was a negative correlation. So the lower the zinc, the worse the insulin resistance, right? So this is something that we want to be mindful of in looking for more zinc. Cadmium, totally different story, right? So in humans with elevated cadmium levels, necrosis and degeneration of pancreatic beta cells. Not good, right? So serum insulin went down, glucose levels were up in those elevated cadmium levels. Same goes for mercury, right? They infect these mouse cells and pancreatic beta cells with mercury through an abundance of ROS, this big inflammatory cascade. The oxidative stress was up, insulin production was down. The same goes for nickel. Nickel in rats caused impaired DNA repair, which led to an increase in blood sugars. So you have to wonder, reading all of that, what are the mechanisms that these metals are doing this, right? So some of them are causing inflammation, right? I've talked a bunch about how iron, through the Fenton reaction, causes advanced oxidation, which causes this huge influx of inflammatory cascades. And so with that oxidative stress, what is it affecting, right? It could be impairing the existing pathways. DNA may be being broken and is unable to repair itself. It could be affecting the membranes of the cells themselves and causing them to spill out and die. It could affect the proteins, right? Insulin resistance having to do with the glycosylation of the insulin receptor protein. And then also mimicry and changing the binding capacity for important things, right? So we mentioned before how important zinc is and how toxic cadmium is. They found that in a solution where they had both cadmium and zinc, the binding capacity of the zinc receptors was significantly stronger for cadmium. So if you have too much cadmium, not enough zinc, cadmium's taking over zinc, and that leads to bad things. Same goes for arsenic, for a phosphate group in the metabolism of glucose. Arsenic for sulfur. Sulfur is incredibly important in the iron-sulfur clusters that are responsible for glucose metabolism in the mitochondria, right? So these heavy metals kind of act like imposters, and when they fill the roles of what is supposed to be there, they cause distress in the cell. Now, you may be asking yourself, well, Bowie, how do I find out about my heavy metals? Now, this is an actual HTMA, hair trace mineral analysis of mine. So you can look online, you can find HTMA, you clip off little bits of your hair and you send them off to a lab to have them analyzed for heavy metal content. They will send you back a list of all of the things that were deposited in your hair. And so it gives you the full gamut of kind of your standard array of minerals, like some of the good ones, and then your toxic elements, all of the uranium, arsenic, mercury, cadmium, lead, the ones you really don't want to be there. So super valuable tool. I recommend that everyone get it done just to kind of set a baseline for your heavy metal content. And now let's talk about the diabetes and the gut microbiome. Okay, so this is one of the biggest hot topics in disease development for type 2 diabetics as well as type 1, that kind of gut brain axis and the development of disease. So These are just some of the papers that I have used to reference here, but they talk a lot about the specific strains of bacteria that are necessary for health and the ones that become more prevalent in a disease state. So for those experiencing autoimmune conditions, specifically related to diabetes or insulin resistance, these here are all of the ones that are increasing, okay? Those over here are the ones that decrease in states of inflammation, right? And some of these are familiar, right? Lactobacilli, bifidobacteria, those are very common in yogurts, fermented dairy products like yogurt and kefir. And then you have other here like the Escherichia, like Escherichia coli, E. coli, which we all know as being a very toxic bacteria in our body. So interesting to correlate, like, okay, these are the good bacteria. We don't have enough good bacteria in states of inflammation. And then we have all of these bad bacteria in states of inflammation. Now, the next part of that, okay, so if you're sick, you have low levels of this, high levels of this. What does that actually do? What are the good bacteria doing? What are the bad bacteria doing? Now, a couple different ways in which bacteria influence your health. Boosting digestion and your ability to absorb nutrients. Modifying glucose metabolism, right? The speed of your digestion is going to affect how quickly food is being absorbed, macronutrients specifically. Promoting intestinal wall health. So making sure that no matter how fast that food is moving through, are your intestinal cells, the cells that are actually absorbing the food and making it available to your body, are they healthy enough to A, absorb the nutrients, and then B, protect you from invading toxins, right? And so with the toxins in your gut, on your food, are your bacteria neutralizing those toxins and disposing of them properly? And I'll just, a quick little note here, there is still some ambiguity and inconsistencies in the bacterial presence. So there are some, I'll mention one name here, the Akkermansia muciniphila. This is one that helps with breaking down mucus in your intestines. There are some studies that find that in disease states it's elevated. There are some that find that it's not elevated in other disease states. The whole idea of striking a balance persists. What the actual balance is still unclear. So when you consider the gut bacteria, chicken or the egg problem again, do these bacteria create a toxic environment, or was the environment toxic and the bacteria simply filled in where there was space to fill in? You know, so when we look back at those good and bad bacteria, right? So, okay, I'm inflamed. I have less lactobacilli and more bacteroidecidal. Am I sick because of that, or was I sick and this is how it resulted? You're not sure which one came first. And what are the ways in which we can positively influence the bacterial balance, right? Probiotics, prebiotics. Obviously, food choice is going to have a part to do with this. Plenty of ties behind pro-inflammatory foods, altering gut microflora, lots of different factors that go into bacterial balance. And then are there external factors outside of just the gut itself that are influencing what's happening in the gut? Things like stomach acidity, your appendix health, your appendix being a source of a lot of good bacteria, your liver health, your liver being a really important exocrine organ in digesting foods and making sure that the foods are broken down to a point that the bacteria can do what they need to do. Next, we're going to talk about the emotional stress and the trauma behind the development of diabetes, as well as post-diagnosis. So this is something a lot of people also don't know about diabetes, is that people can go through traumatic experiences in their life. Parental divorce, I've talked to soldiers who have come back from war and developed diabetes without any sort of other complicating factor. So psychological stress as a factor potentially contributing to the pathogenesis of type 1 diabetes, early life trauma and diabetes management, how all of these things go into proper management of the disease. And it turns out there's a lot of different things at play. So there was this one meta-analysis that was looking at the factors, the different details of all of these different cases of type 1 diabetes, and they found these correlations with socioeconomic status. Those in poorer communities had higher rates of chronic disease and the development of diabetes. It was common for within the 2 years before the development of diabetes that there was some sort of traumatic life event. Could have been parental divorce, moving houses, family illness, change in their financial situation. One of the parents loses a job, as well as change in schools. Poor school performance was another one. There's just something a little bit off that causes these huge influxes in stress for the child. These particular studies were in children, but in anyone's life, it happens to adults as well. And there are well-documented cases of stress altering glucose metabolism. So just in this one paper here, stress-induced hyperglycemia, increased gluconeogenesis, and insulin resistance are important factors of the hormones and cytokines that are responsible for inducing high blood sugar as a result of stress, right? Gluconeogenesis is the liver creating sugar, releasing sugar into the bloodstream. Insulin resistance, obviously, changing the insulin receptors so that glucose stays in the blood and is not able to get into the cell. But this paper in particular found that increased levels of this one inflammatory marker, interleukin-6, in the serum was associated with insulin resistance, which promoted high blood sugar by releasing glucose from the liver's glycogen stores. Now, a lot of different deep-seated effects. It's not just IL-6. Cortisol is a huge factor in this. It mobilizes sugar, right? That fight or flight response of the sympathetic nervous system has a huge role in mobilizing sugar and preventing it from being taken out of the blood. The idea of chronic nervous system stimulation and living in a state of stress. You're not giving your body enough time to recover. You're depleting glycogen stores. You are living in this state of chronic insulin resistance. It also, another factor of high cortisol and high sympathetic nervous stimulation is wasting electrolytes, right? Things like sodium, potassium, and magnesium are incredibly important for proper glucose utilization. When you are stressed, those things get lower. So that one paper had a really great chart here talking about all of the different factors that go into how stress induces hyperglycemia. So the cytokines, the hepatokines, these are all part of the immune response. TNF-alpha, IL-6, IL-1, and the FOXO genes all have a high correlation with the development of insulin resistance. The particular hormones, right? Glucagon from the liver, growth hormone from the liver and the pancreas as well, cortisol from the adrenal glands, catecholamines, they all lead to increased sugar release from the liver and the muscle, right? So not only are you resistant to insulin, but you're also doubling down on increasing your sugar load. And then on top of that, cortisol doesn't just increase your sugars, it also increases your insulin resistance. So it's kind of this positive feedback loop that leads to elevated blood sugars. So there's a lot going on here. And one thing to think of with all of these balls in the air is there something uniting all of these theories? Each one of these that I've talked about is taken at kind of the surface level, right? Like, if your gut microbiome isn't good, you can't build anything steady on top of it. But with all of my chicken or egg questions is there, we've taken the gut microbiome, we've taken the genetics, the parasites, the mold, the heavy metals as kind of the base layer. Is there something underneath that is allowing for all of these conditions to exist? That is my real search in all of this, right? And considering stress, are there ways to fortify the body against stress? What are the things that predispose certain children to developing diabetes and not others, right? Every kid goes through stress. Every kid has stress in some degree, some form, right? Why is it that some are getting diabetes and some aren't, right? There's some compounding factor here as to why some get it and some don't, right? Now, looking back at each of these theories, each has a very strong correlation with disease development. I completely understand why people learn about these topics and are like, oh yeah, it has to be the microbiome or it has to be parasites. I understand the logic behind how it comes about, but none of them are mutually exclusive, right? If you have, you can be infected with parasites. You have an inflammatory response. Inflammatory responses can change your DNA. If you have your, heavy metals present, that could be a source of inflammation. That could be what actually kills your diabetes or causes your diabetes. That could create an environment where other things come in that cause your diabetes. So you're never sure. Everything seems so enmeshed. Nothing rises above the other as being more true or more possible than anything else. So a really good question is, can any theory here be described as a root cause independent of the others? There are numerous sources of inflammation, internal and external, right? The food we're eating, the animals that exist within us that can both help us or hurt us. Are we living in a polluted environment that is negatively impacting our ability to heal? My biggest goal in all of this is to find common ground within these theories. I don't think that any one of them is like the kingpin from which everything else is constructed on. There has to be some sort of underlying level that brings all of these together, right? Can we simplify each of these theories to consolidate our healing efforts? We have one school of thought saying, well, if you heal your gut microbiome, everything gets better. You have others saying, well, if you get rid of parasites, your microbiome gets better. It's like, which comes, there has to be something else underneath making this so. Not every person experiencing these develops the disease. What are we missing? What are we missing? Okay. So that's where I'm going to leave it here. Again, next up, we're going to talk about each of these theories in a more detailed way and tie in some possible uniting factors that are going to make each of the theories seem more like a symptom and less like the cause, right? I also want to talk more about HLA genes and learn more about how they're tied to diabetes as well as other autoimmune conditions. and the bacterial species to know, right? We talk about gut health, gut health, gut health. What does that actually mean? What species do we want? What species don't we want? Okay. So to stay up to date with all of this, go ahead and subscribe to my channel. Follow me on TikTok at Bowie_Madison. Thank you so much for being here. I love the community that we've begun to build. If this has helped you or you think this can help someone you know, please share it, spread the word. The more people we have involved, the better. And thank you. This is episode 31 of Diabetics for Diabetics Radio. My name is Bowie Madison. Thank you so much and enjoy the rest of your day.